Okay, let's do a couple of examples. Let's look at this first one. We have number 1 is equal to cosine x times tangent x, and that's going to be equal to sine x. And so using the note card with the strategies, here's how I would approach this problem. First thing I would say, well, definitely this is the more difficult looking side. So I'm going to rewrite this over here where we have more room. Okay, so what I'm going to do is I'm going to work with this left-hand side, and I'm going to try to make this become sine x. Now, I can't just say, okay, well, sine x is equal to sine x. Now, believe it or not, I know some of you are thinking, well, that's very ridiculous. This happens quite often. You can't just jump down here and say this. Remember, you cannot skip any steps at all. So that's not valid. So what I'm going to do is using note card, the note card with all of the identities, the reciprocals, and all those things, I'm going to try to change this left side to make it look like sine x. Now, here's something that you might want to keep in mind. Always try first. First, you're always going to work with the more complicated side. You're going to try to just work with one side. Sometimes you have to work with both. You always want to try to work with the most complicated side, and you want to try to convert everything to sines and cosines. Okay? That's your first line of defense. Okay? So just like when you have bad breath, your first line of defense should be brushing your teeth. Some people just chew gum, but you should brush your teeth first. So our first line of defense in proving trig identities is try to change everything to sine or cosine or both. So I've got a cosine, so I'm going to leave that there. So then I'm going to think, well, how can I change tangent to something with sine in it, or cosine, or both? And if we look at our quotient properties, we know that tangent, you don't have to write this, I'm just going to write out to the side. We know that tangent, theta, is equal to sine theta over cosine theta. Okay? So I'm going to use that information, and I'm going to have, well, I'm leaving this cosine x here. So tangent x is equal to sine x over cosine x. So times sine x over cosine x. And I'm keeping this just going down here, and this is, you know, still sine x here on this side. Well, what happens here? I've got multiplication going on, and I've got a cosine x times a fraction, so I can make this cosine x a fraction by putting it over 1. And what happens, if you remember your cross-reducing properties and multiplication with fractions, these two cancel each other out. And so this becomes a 1 and this becomes a 1. So 1 times sine x is sine x. 1 times 1 is 1. And then obviously sine x over 1 is sine x. And voila, we have sine x is equal to sine x. And we have successfully proven that cosine x times tangent x is an equivalent expression to sine x. Okay? We're going to look at a few more. Let's just take a look at number 2. We have tangent x is equal to sine x times secant x. Using my same little principles as number 1, I'm going to try to look at the more complicated side and change it into the side that looks a little bit more simple. So I've got a tangent x over here. I'm going to leave this alone for now. And remember, I'm also going to think in terms of changing everything to sine and cosines. So I've got a sine x here, so I'm going to leave that sine x there. Well, how can I turn secant x into something with sine or cosine? And if you look at your reciprocal properties, we know that secant x, or secant theta, is equal to 1 over cosine. So I'm going to use that identity that reciprocal property there. And secant x becomes 1 over cosine x. And it is multiplication. And so I put sine x over 1, and I can simplify this further. Sine x times 1 is sine x. 1 times cosine x is cosine x. And if I look down at my note card again, I know that sine x over cosine x is tangent x. Using the quotient property, and on your note card it would be number 4. And so I have tangent x is equal to tangent x, and I have successfully proven that tangent x is equal to sine x times secant x. Let's look at one that is a little bit more complicated. Let's take a look at number 4. We have cosecant squared x times 1 minus cosine squared x is equal to 1. Now there's a few ways that we can approach this, and by the way that I'm doing this, there's typically more than one way to do these proofs. Somebody may have approached it from a different direction and still was able to use all the rules properly, and you prove it. I'm just trying to give you the at least what I see as the easiest way to prove them. So if I look at this problem, one thing I could think is, well, the note card did say I could do some distribution, and I could distribute here. But if I distribute here, it might make things a little bit more complicated. The reason why I would not start off by using distribution is because if I see something like this, this is an equivalent to, if you look at one of your Pythagorean identities, 1 minus cosine squared x is sine squared x. And since I want to change things to sine or cosine whenever I can, anytime I see something like this, I'm probably going to change this to sine squared x. And then if I look over here at cosecant squared x, if I look at my trig identity, or my Pythagorean identities, I see that that's 1 plus cotangent squared x. But that doesn't help me any, because 1 plus cotangent squared x doesn't make things easier. So there's something that we need to add to your identities note card. It's something that you can infer. If you know that cosecant x, looking at your reciprocal identities, is equal to 1 over sine x, and that's your reciprocal, that's the very first one, the very first reciprocal identity. If cosecant x is equal to 1 over sine x, then cosecant squared x is equal to 1 over sine squared x. Okay? And so this is how I would approach this problem. I would change 1 minus cosine squared x to sine squared x. And I would change cosecant squared x to 1 over sine squared x. Multiplication, put the sine squared x over 1. And most of you are already seeing that this is 1 because of your cross reducing here. You get a 1 here and a 1 here. And 1 times 1 is 1. 1 times 1 is 1. And 1 over 1 is 1. So this is 1 is equal to 1. And we've proven it. So sometimes, I remember when I first started learning how to do these trig identities, and I remember it being a headache. Lucky for you, you have awesome instruction here. I can tell you that sometimes when you start to do these, you may go down a wrong path. You may start to prove one of these things and find yourself making a mess of it. That's okay, just scratch it out or erase it and start over. Okay? If you find yourself going into something and making it really complicated, sometimes you have to make it a little complicated, but sometimes, most of the time when it becomes really complicated after it was simple, you've probably taken a wrong turn. And so that's that. I will start you off with this on some practice problems, and then we will get into some more complicated problems in the next day or so. And just use your note card that gives you strategies, and remember to work with the most complicated side first and think of changing things into terms of sine and cosine.